and the signal on your right is split into three signals. Let's call it as signal B. So from this structure, can you identify which signal is for which set of protons? I really hope that you have identified at least the sets of protons. This is one set of proton and this is the another set of proton. So you can say that one set is for CH2, the other set is for CH3. So tell me which signal is for CH2 and which is CH3. I will give you hint, people, everybody. N plus 1 rule. Use N plus 1 rule. So for CH2, how many adjacent protons? 3. 3 adjacent protons. So you have N is equal to 3 plus 1. So you expect part 8 for CH2. Now for CH3, there are 2 protons adjacent to it. So 2 plus 1, N plus 1, 3. So CH3 will give you a triplet. So I hope that revised the rule of N plus 1 for many of the students. Now, since CH2 and CH3, they are adjacent to each other, they are connected to each other, J value for CH2 group and J value for CH3 group, it will be same. मतलब क्या, adjacent group, जो group एक दूसरे को directly connected है, उनका J value same होता है. Now, depending on what type of carbon the hydrogens are attached to it will decide the value of coupling constant. So I'm starting with my lecture today. 34 students are there. ठीक है. So let's see different types of coupling constant, different types of J. The most commonly encountered type of coupling is between hydrogens on adjacent carbon atoms, and this is very much understandable that carbon which are connected to each other and bearing hydrogens, these two hydrogens, their nuclei will couple with each other. Okay, there will be coupling and they will cause splitting of each other's signal. This is called as vicinal coupling. That is the hydrogen which is in vicinity of each other. So that's why the word vicinal coupling. Podos wala, ek dusre are getting coupled. So it is designated J3. Okay, since the hydrogens are divided by 3 bonds, 1, 2, 3. So it is J3 coupling. Okay, another type of coupling can also occur in special cases. Now, the special case where the functional group attached here will be different, and when I say different, it meant for one hydrogen and completely different environment for this hydrogen. Now, this is very rare case. It may happen, extremely rare, but you must be getting some idea. If this is the case, the environment of these two hydrogens is almost identical. Okay, if they are identical, do you think coupling will occur? In case there is no coupling, there will be no splitting because the environment is almost identical. But cases it may happen that it is not zero. Okay, so J2 or geminal coupling. See, Gemini, you can say twins. Okay, so they are almost identical. Okay, these two hydrogens are almost identical, so they are like twins. So the name geminal coupling. So geminal coupling does not occur when two hydrogens are equivalent, as I said, due to rotations around the other bonds. So that's why J2 for most of the cases is 0. There is no coupling. So let us see the cases where it is considered as can say significant. So vicinal, we have already seen. The value of J in that case is between 6 to 8 hertz, and two hydrogens are separated by 3 bonds. So it is type of J3 coupling. The other is trans type of coupling, where you have a bulky group attached here, a bulky group attached here, and those bulky groups are trans to each other. I hope you know what is cis and trans. So these two hydrogens may couple with each other, and the coupling causes the separation of the signal, splitting of the signal by 11 hertz to 18 hertz. Again, there are 3 bonds involved, so it is J3 coupling. As in the case of trans, there is cis coupling constant. Okay. Now, so the bulky groups are on the same side of the double bond. So the value may be between 6 hertz to 15 hertz. The type remains same, it is J3. Now, geminal coupling. What if there are 2 different bulky groups here? Okay, so suppose here it is a phenyl group, and here it is a bulky group, say phenanthrene, okay, or say pyridine group. Okay, let us call it as pyridine group. So the environment faced by this hydrogen is slightly different than this hydrogen, so they are not equivalent. So there will be definitely coupling occurring. Okay, so if this is the case, the value of coupling constant may vary from 0 hertz. 0 will be when both of them are completely identical, to maximum of 5 hertz. Now this is the only type where the coupling is of J2 type. Now, in case of cycloalkanes, there are 3 types of coupling that can be observed. Okay, coupling between 2 axial hydrogens, then the value of the coupling constant will vary from 8 to 14 hertz. It may be between 1 axial and 1 equatorial. The value may vary from 0 to 7, or it may be between 2 equatorial hydrogens. The value may vary from 0 to 5. All these, if you will see, they are separated by 3 bonds. They're separated by 3 bonds. Now, one may ask, sir, why not this axial hydrogen is coupling with this equatorial hydrogen? If that is the case, we cannot consider that as a type of, say, cyclohexane coupling. We can simply call it as a geminal coupling. Coupling between these two, we can simply call it as geminal coupling. I hope the concept is clear to you. Let us see now.